Hi guys, welcome back to my channel. Today let us learn about alkynes. They are unsaturated carbon compounds with a general formula CnH2n minus 2. They give addition reaction and hydrogenation reaction. So here in alkynes we can mainly observe three bonds between two carbon atoms. And again talking about the simplest alkyne would be ethyne with the molecular formula C2H2. Next member would be propine C3H4 and then butane C4H6 and so on. Here again, students, we can observe there is a CH2 unit difference between each alkyne group. So propine would be, or rather, if you add CH2 group to ethyne, we would get propine. Similarly, if you add CH2 group to propane, we would get butane and so on. So now let us understand by knowing the structure of few compounds. So here we have ethyne. So the root word eth means two carbon atom, and since it is an ine, YNE refers to three bonds between two carbon atom. So this is the basic skeleton structure for ethyne. Now the remaining step would be to satisfy the valency of each carbon atom. That is, valency of carbon is 4. So I would write one bond with two C1. Similarly, one more bond of hydrogen with hydrogen on C2. So this is the structure of ethyne. So here you can observe there are two carbon atoms and there is a triple bond between two carbon atoms, and every carbon you can observe there is tetravalency. So there are four bonds around each carbon atom. So the molecular formula would be C2H2. This is ethyne. Similarly, next let us go with propine. Propine, the root word is prop, so three carbon atom, and since it's an ine, so you can either write a triple bond at C1 or a triple bond at C2. However, at any position we can write, because we are not learning about positional IUPAC rules. So here we are only, generally we are just talking about writing the structure of propine. So triple bond can be at C1 or either at C2. So here I have written at C2 carbon. Now the next step would be, so there's a basic skeleton. Now the next step would be satisfying the valency of carbon. So if you look at C1, there is one bond. So it still needs three bonds to have 4 valency. And C2, if you observe, it is already satisfied with one bond on left and three bonds on right. So 4 bond. And on the C3, you can expect one more bond with hydrogen, because there are already three bonds with C2 carbon. So this is going to be the structure of propine, and the general formula would be C3H4. C3H4 would be the general formula of propine. Now next molecule would be butane. So again here talking about but would be C4, and ine if I suppose write at C2 carbon. So this is a basic skeleton for butane. Now the remaining would be to satisfy the valency. So C1 will have three bonds with hydrogen. C2 you can observe it's already satisfied with four bonds around itself. C3 again satisfied. C2, C3 are already having four bonds around themselves. C4 again having one bond. So the remaining would be bonded with hydrogen. So this is the structure of butane, and the general formula would be C4H6. Sorry, molecular formula would be C4H6, and this is the structure of butane. Similarly, next let us write pentyne. So pent means 5 carbon atom. So if I write a triple bond again, at C1, so C1 gets a triple bond. Now the remaining work would be to write the valency, make sure that each carbon is having valency of 4. So C1 is having valency 4. Similarly, C2 is already having 4 valency satisfied. Now coming to C3, there are 2 bonds. Now the remaining would be to write the other 2 hydrogen atoms, bonds with the 2 hydrogen. Similarly, C4 again, if you talk about C4, again there is 2 hydrogen to be written. and C5 you can see only one bond are there, so hence three more bonds you have to write with hydrogen. So this is the structure of pentine, and the general formula would be C5H8. C5H8 would be the molecular formula, sorry, and then the pentine is having a structure of this. So this completes the structure of alkynes. Thank you very much.